Hello everybody. In this video, we will explore the concept of constellation and learn how to identify them in the sky. Readings for chapter 2 can be found on pages 18 to 34 of your textbook. When we look at the sky on a clear, dark night, we can only see about 5,000 stars with the naked eye. This represents only a tiny fraction of the nearly 200 billion stars that make up the Milky Way galaxy. The sky is divided into regions, each with a boundary around it. Each of these regions is a constellation. You can think of the boundary of a constellation as the boundary of a state. Wherever you point on a map of the US, that point is part of a state. Similarly, wherever you point into the sky, that point is part of a constellation. Not all stars are part of a constellation, because most of them cannot be seen with the naked eye. In a constellation, a group of stars appears to form a pattern or picture in the sky. In this image, we see 4 of the brightest stars in the night sky. Sirius, the brightest of all stars in the sky. Rigel, the 7th brightest star. Procyon, the 8th brightest star. And Betelgeuse, the 10th brightest star in the night sky. 3 of these stars form a well-known asterism called the Winter Triangle. It is called like that because this arrangement is visible for much of the night during the winter in the northern hemisphere. Each of these stars is part of a different constellation. Sirius is the brightest star in the constellation Canis Major, or Big Dog. Procyon is the brightest star in the constellation Canis Minor, or Small Dog. Betelgeuse and Rigel are the 2 brightest stars in the Orion constellation. Orion is known as the Great Hunter in Greek mythology. Between Rigel and Betelgeuse, there is another well-known asterism called the Three Sisters. The Three Sisters are 3 stars called Alnitak, Alnilan, and Mintaka. They are evenly spaced in a straight line. Betelgeuse, a red supergiant, is found in the right shoulder of the Hunter, while Bellatrix, a star almost 9 times more massive than the Sun, is in the left shoulder. Rigel is found at the left knee of the Hunter. At the bottom left of the chart is Sirius, the brightest star in the night sky and the brightest of the constellation Canis Major. Because of that, Sirius is also known as the dog star. It appears bright because it is relatively close to the solar system, 8.6 light years away. In Greek mythology, Canis Major represents one of Orion's hunting dogs. And it appears to be pursuing a hare at the Lepus constellation, seen here on the right. Procyon, the brightest object in the constellation Canis Minor, or Small Dog, is in fact a binary system made up of Procyon A, a main sequence star, and Procyon B, a much smaller white dwarf. Constellations are easily recognizable patterns that help people orient themselves using the night sky. They have been used for thousands of years by many civilizations. Modern constellations like the peacock, the telescope, and the giraffe were identified more recently by astronomers using telescopes. In 1930, the International Astronomical Union officially listed 88 modern and ancient constellations and drew the boundary around each of them. The boundary edges meet, dividing the imaginary sphere stars. Astronomers consider any star within a constellation boundary to be part of that constellation, even if it is not part of the actual pattern or picture that defines that constellation. When you look at different stars in a constellation, are they all located at the same distance from us? What do you think? Do they all belong to the same star cluster? They all lie at about the same distance from Earth? Or they may actually be quite far away from each other? The correct answer is C. The stars in a constellation may actually be very far from one another and may not belong to the same cluster. Each constellation is a collection of stars that are distributed in space in 3 dimensions. The stars are all at different distances from Earth and different distances from each other. They appear to be in the same plane because we are viewing them from very, very far away. Stars vary greatly in size, distance from Earth, and temperature. Dimmer, weaker stars may be smaller, farther away, or cooler than brighter stars, or they may not. By the same token, the brightest stars are not necessarily the closest ones. The illusion of stars all lying at the same distance in the constellations allows us to define the celestial sphere. It doesn't really exist, but it is a useful tool for learning about the sky. Here are some definitions of the main components of the celestial sphere. The celestial equator is a projection of Earth's equator into the celestial sphere. The north and south celestial poles are also projections of Earth's north and south poles into the celestial sphere. The ecliptic is the annual apparent path of the Sun around the celestial sphere. The ecliptic path is tilted because the planet is tilted on its axis in relation to the Sun. The tilt is about 23.5 degrees. Another feature we can see painted in the celestial sphere is the Milky Way. Our galaxy is called the Milky Way because it appears as a milky band of light in the sky when you see it in a really dark area. This Milky Band is actually the plane of the galaxy. When we look into the galactic plane, the Milky Band, we are actually looking towards the center of the galaxy. When we look to the north or to the south of the Milky Band, we are looking into the rest of the universe, to outside the Milky Way. This slide is another representation of the same phenomenon. When we look into the galactic plane, represented here by the blue arrows, we are actually looking towards the center of the galaxy. When we look out of the galactic plane, north or south of the Milky Band, we are looking into the rest of the universe. The local sky is only the portion of the celestial sphere we can see in our location. The local sky looks like a dome because we see only half of the celestial sphere. Some features of the local sky include the 4 cardinal directions, north, south, east, and west, the horizon, whose altitude in angle is 0, the zenith, which is an imaginary point directly above a particular location in the vertical direction. The altitude of the zenith is 90 degrees. And the meridian, which is an imaginary half circle that passes through the zenith and stretches from the horizon due south to the horizon due north. These reference points are useful if you want to locate any object in the sky, such as planets and stars. To locate an object's position, all we need to do is to specify its altitude above the horizon and its direction along the horizon. For example, the location where the observer in the slide is pointing to is an altitude of 60 degrees in the southeast direction. Using only the naked eye, we have no way of judging the true or physical distances or sizes of objects in the sky. All we can do is measure the angular distances and sizes of these objects. Here are a few ways you can estimate angular sizes and angular distances in the local sky using your hand and fingers. First, you need to hold your hand at arm's length. Then stretch your thumb and little finger as far from each other as you can. The span from tip to tip is about 25 degrees. Do the same with your index finger and little finger. The span from tip to tip is 15 degrees. Now clench your fist at arm's length and hold it with the back of your hand facing you. The width is 10 degrees. If you hold your 3 middle fingers together, they span about 5 degrees. And finally, the width of your little finger at arm's length is between 1 and 1.5 degrees. Now let's explore some of the patterns we see in the sky. What do you think is the feature the arrow is pointing to in the figure below? Is it the zenith? Is it the north celestial pole? Or is it the celestial equator? This is the celestial pole. Since this picture is taken at the northern hemisphere, at Arches National Park in the state of Utah, this pole is the north celestial pole. The concentric circles we see on a time-lapse image are the path of stars in the local sky. Because Earth rotates from west to east, the stars appear to circle in the opposite direction, from east to west. Stars located near the celestial pole are called circumpolar, and they never set, meaning we can see them all the time. Because we are in the northern hemisphere, we cannot see the stars near the south celestial pole. These stars never rise. They always stay below the horizon. Similarly, an observer on the southern hemisphere cannot see the same circumpolar stars we see in the northern hemisphere. All other stars can be seen by observers located on both hemispheres. They rise in the east and set in the west. The arrow here is pointing to one of the few circumpolar stars that are always above the horizon in the northern hemisphere. For observers in the continental United States, the Big Dipper, Little Dipper, and Cassiopeia are examples of star groups in the north circumpolar zone. They can only be seen in the northern hemisphere. The stars we can see in our local sky depend on two things: the latitude of the observer and the time of the year. They depend on the latitude, which is your position above or below the equator, because your position determines which stars and constellations remain above and below the horizon. The local sky for an observer at the North Pole, for example, at latitude 90 degrees north, is indicated by this figure. This observer sees the North Celestial Pole overhead at the zenith. The celestial equator, which is 90 degrees from the zenith, would lie along the horizon. Watching the stars during the course of the night, they would all circle around the celestial pole, with none rising and none setting. Only that half of the sky north of the celestial equator is ever visible to an observer at the North Pole. Similarly, an observer at the South Pole would see only the southern half of the sky. For an observer at 34 degrees south, the North Celestial Pole is 34 degrees below the horizon, and thus never visible. As Earth turns, the whole sky seems to pivot around the South Celestial Pole. For this observer, stars within 34 degrees of the South Pole can never set. They are always above the horizon, day and night. This part of the sky is called the South Circumpolar Zone. On the other hand, stars within 34 degrees of the North Celestial Pole never rise. We can use the altitude of the celestial pole to define our own latitude. For example, in the Northern Hemisphere, to locate the North Celestial Pole, you need to find Polaris, the North Star. The pointer stars of the Big Dipper always point to Polaris. As the Big Dipper turns in the night sky, extend the trace of the two pointer stars. The location where these lines intercept is the location of Polaris. To find the South Celestial Pole, extend the lines of the Southern Cross at two positions in the sky. The location where they intercept is the location of the South Celestial Pole. Once you find the celestial pole in your location, measure the altitude in angles, using your hand and fingers as we already saw. Let's see if you understand the relationship between your latitude and the altitude of celestial poles. If the altitude of Polaris, the North Star at your location, is 50 degrees above the horizon, what is your location? The correct answer is 50 degrees latitude north. It is north because of Polaris. Polaris is a North Star. And it's 50 degrees latitude because Polaris is at 50 degrees angle above the horizon. The stars we can see in our local sky also depend on the time of the year. That's because Earth's orbit changes the apparent location of the sun among the stars. Because of that, stars that are in our field of view during the day cannot be seen. They are obscured by the sun, which is too bright. We can only see stars and constellations during the night when the sun is at the opposite end of the zenith. In this example, the constellations we can see at night in June are Libra, Scorpius, Ophiuchus, Sagittarius, Capricornus, and Aquarius. The others are in our meridian but during the day, but we cannot see them because of the sun. The opposite is true in December. In summary, we learned that we can only see a small portion of the stars in the Milky Way on a clear dark night. These stars are spread through the sky into 88 regions that we call constellations. The illusion of stars all lying at the same distance in the constellations allows us to define the celestial sphere, which doesn't really exist, but is useful for identification and classification of constellations. The position of an object in the local sky can be specified by its altitude above the horizon and its direction along the horizon. Stars rise and set, not because they are moving, but because Earth is rotating on its axis. The stars we can see in our local sky depend on two things: the latitude of the observer, which determines which constellations are visible and which are hidden, and the time of the year, which determines which constellations appear at night and which will appear during the day. Thank you for watching, and I see you in the next video.